local jurisdiction building code determines which version of the National Electrical Code, or NEC, applies. If electrical wiring is done based on a newer version of the NEC, but the jurisdiction uses an older version, it could fail inspection. Regarding ground wire connections, the 2017 NEC Section 250.148 V requires crimp-on connectors for ground connections where more than one conductor is connected to a threaded enclosure nipple or bus. Wire nuts are not specifically prohibited, but crimp-on connectors are preferred. Wiring ground fault circuit interrupter, or GFCI, outlets on separate circuits is not necessary, but provides additional protection. Connecting the bathroom fan to the load side of a GFCI outlet is acceptable. However, it is important to calculate the total load. Firstly, a hairdryer consumes between 1200 and 1800 watts. Secondly, a curling iron uses between 200 and 500 watts. Thirdly, a bath fan requires between 100 and 300 watts. The cumulative load of these devices could exceed the ampacity of the circuit breaker, which is typically 15 or 20 amps. If the total load is excessive, the breaker may trip. It is recommended to use a 20 amp circuit for the bathroom to accommodate the potential load. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. Understanding key aspects of the NEC is crucial for anyone involved in electrical work, from electricians to general contractors and homeowners. Here are some fundamental concepts to keep in mind. Firstly, overcurrent protection. Circuit breakers and fuses are essential for protecting electrical circuits from overloads and short circuits. They are designed to interrupt the flow of electricity when the current exceeds a safe level, preventing overheating and potential fires. The NEC specifies the appropriate size and type of overcurrent protection devices for different circuits based on their ampacity and the type of load they serve. Secondly, grounding and bonding. Grounding and bonding are critical safety measures that help to minimize the risk of electric shock. Grounding provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. Bonding ensures that all metallic parts of an electrical system are electrically connected, creating a low impedance path for fault current. The NEC has detailed requirements for grounding and bonding, including the size and type of grounding conductors, the location of ground rods, and the bonding of metallic enclosures and equipment. Thirdly, wiring methods. The NEC specifies the acceptable wiring methods for different applications based on factors such as voltage, current, location, and environmental conditions. Common wiring methods include non-metallic sheath cable type NM, rigid metal conduit RNC, electrical metallic tubing EMT, and flexible metal conduit FMC. Each wiring method has its own advantages and limitations, and the NEC provides guidelines for proper installation and support. Fourthly, box fill calculations. Electrical boxes are used to enclose wiring connections and protect them from physical damage. The NEC limits the number of conductors and devices that can be installed in an electrical box based on its size and volume. Box fill calculations are used to determine the maximum number of conductors, devices, and fittings that can be safely installed in a box. The NEC provides formulas and tables for calculating box fill, taking into account the size of the conductors, the number of devices, and the presence of internal clamps and fittings. Fifthly, conductor ampacity. Conductor ampacity is the maximum amount of current that a conductor can safely carry without overheating. The NEC specifies the ampacity of different conductors based on their size, insulation type, and ambient temperature. The ampacity of a conductor must be derated when it is installed in certain conditions, such as when it is bundled with other conductors or when it is exposed to high ambient temperatures. The NEC provides tables and formulas for derating conductor ampacity. Sixthly, GFCI protection. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electric shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault, which is a leakage of current to ground. The NEC requires GFCI protection in certain locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Seventhly, arc fault circuit interrupter, or PSI protection. Arc fault circuit interrupters, or PSIs, are designed to protect against electrical fires caused by arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. The NEC requires PSI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. Eighthly, equipment grounding. Equipment grounding is the process of connecting the non-current carrying metal parts of electrical equipment to ground. This provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the equipment. The NEC requires equipment grounding for most electrical equipment, including appliances, motors, and lighting fixtures. Ninthly, bonding of metal-water piping. The NEC requires the bonding of metal-water piping to the electrical grounding system. This is to ensure that the water piping is at the same electrical potential as the grounding system, which helps to prevent electric shock. Tenthly, surge protection. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges, which are sudden and transient increases in voltage that can damage or destroy electronic devices. The NEC recommends the use of SPD in certain applications, such as in homes with sensitive electronic equipment. By understanding these fundamental concepts of the NEC, you can ensure that your electrical installations are safe and compliant with code requirements. Always consult the latest edition of the NEC and seek the advice of a qualified electrician for any electrical work.